am a teacher from Shanghai Urban Construction Vocational College. We're glad to invite Ms. Zhang to explain the relevant knowledge of Smart City to us. Over the past 20 years, he has been at the forefront of technology in world environment management and has rich successful experience at home and abroad, such as flood control, comprehensive management of world environment, water system simulation, and water-sensitive city construction. He is familiar with hydrology, water resources, and hydraulics, and has rich experience in multi-professional project consulting, covering the professional fields of smart city construction, water resources, and stormwater management, municipal water supply and drainage, water ecological restoration, and water environment treatment. Hi, Ms. Zhang. Smart city construction involves land use, buildings, roads, water systems, pipelines, and various smart facilities, making it a highly complex and dynamic process. The modeling is needed in planning and design. And could you please explain the concept of modeling for smart city?
Okay, yeah, good to see you. Yeah, no, thanks for inviting me to be here to talk about smart city and computer modeling, which are quite hot topics these days. Yeah, the first one is what the concept of smart city modeling. I will explain. As we can see, normally in a natural river system, the system has its own natural, healthy system, which has a main channel, floodplain, and also beautiful plants along the river, along the water. We can see this is a kind of natural goal we try to achieve through smart city development. But when we are building city, especially in the last 20, 30 years in China, we have been developing rapidly, building many big scale city in many places. So what has changed is the land use, the natural river system, the natural hydrology. As we normally can see in most cities, we are having some flooding issues, we are having water quality issues or ecological issues. All these were the result due to rapid urban development. As a conceptual diagram showing here, we can see in most cities, we are building some green infrastructure, like the green swale along the roads, and some of the tree pits along the road as well, and also some other in many different ways of green infrastructure. So the concept of those things are to mimic the natural hydrological system, try to compensate the consequences due to urban development. We will see a lot of green infrastructure in many cities. People may not notice, but all these things actually were designed, were built on purpose. Try to mimic the natural hydrological environment. So like a lot of swales, purpose paving, and wetlands, many different types.
As a technical tool, how to build a hydraulic model?
Yeah, this is very technical. So the computer model is try to mimic the natural system, right from rainfall, because everything is sourcing from the rainfall from the sky anyway, and then drop on the ground, and then to mimic the natural water system. The diagram showing here, the first step is to understand the hydrology, how rainfall distribute over a city or over a region or over a catchment, and then how will rainfall process into the ground. Some rainfall will penetrate into the groundwater, some may form overland flow, flow to the downstream. So this is a natural process of hydrology. Computer need to model this process. That's the first step. But then you have to understand the water penetrates as well as how water travels in the pipe system, in the river system, in an urban area or urban environment. Then we are having two scales. One is a big scale at a city scale or at a catchment scale. For example, as we see here, for a city scale, which is the major one for most of the systems we are having, you have to understand what is urban planning. So you need to get a lot of information from urban planning. What is the geographical features? Like you have to understand the digital elevation model or collect the digital elevation data, as well as the pipe system, the river the system, the features or engineering infrastructure. All this information you have to collect and then input into a computer. Then computer will model the pipe system, river system, model the dynamic within the whole major system. But then the computer will identify the problem area, the level of the problem and level of the risk, and then try to understand what are the solutions we might need to take to alleviate the issue. So this is a major city scale and a big one. But down to the next level, which at the source, because we know a city has very big area, but most of the water flows from a catchment block or maybe a commercial area or somewhere. We call it a source catchment. So at the source catchment, within Spondy City concept, we built many green infrastructure, like around the roads or in a residential area or in a commercial or business area. So those green infrastructure need to be modeled properly because there are so many. You can't do it by hand calculation. Again, we have to use computer. As you can see here, so we will model this individual infrastructure by computer model and then to mimic the natural behavior of the water penetrating through this infrastructure and also down to the system. For a single infrastructure, as you can see here, for example, like a swale or rain garden, again, you have to understand how they perform, how they function to manage the stormwater going through this infrastructure. So we need to input various parameters that you can see here, like the infiltration rate, the type of the plants, the type of soil, and the scale of the physical parameter of this facility. All of that kind of parameter will be input, then computer will model the process. So computer can model all sorts of green infrastructure, for example, like the purpose paving, like the infiltration trench, and swales, many other types of green infrastructure. Each type of infrastructure will be modeled by their individual relevant parameters and also the scale of these facilities. Then at development scale, for example, if we are developing for residential area or for commercial area or for some kind of business area, like, for example, as we can see here, is a design for a school, a primary school, which has maybe 20, 30 hectares of area, quite big area. Obviously, you will build many buildings, roads, and also, again, you want to build Spondy City facilities to alleviate the water issue within that development area. Then you build many swales, purpose paving, and some maybe rain tanks, various sorts of facilities. But then in the design, the question is what type of facility you should use, how many you should build. Then that's a design question. Obviously, you need to use a computer model to put all these facilities within your system, and then you test various situations. And then the computer model will show the consequences of the system. For example, like the flow pattern, the water quality treatment efficiencies, and also various sorts of outputs will be presented in the computer model, which will help you to make a decision for the planning, for the design, and also for optimizing your solutions. Very simple example, as you can see here, computer model will calculate the rainfall, calculate the flow within the system, and tell you the consequence, the resultant the flow pattern, and also the efficiencies of removing stormwater pollutants, and also the consequence of the peak flow reduction, that kind of results. So then engineers can make a decisions based on those key figures.
As everyone knows, the application of hydraulic models is a very important part. Could you introduce some about it?
We can see, computer modeling is so complicated. It addresses many aspects, starting from rainfall, from the land use, from how we develop the city or how we develop the urban features, as well as try to test various engineering solutions to achieve our goal, to achieve a natural, healthy water environment. So it covers many aspects. So really for urban development, there are a lot of issues involved, like for planning, for decision making, for policies, and also for engineering solution optimization. So all these aspects will be made depend on the key figures we gain from the computer modeling. So computer model need to address all these planning features, engineering feature, whatever, put all these features together into the model, and then test the model, run the model, get results. So these results are fundamental for us to make policy decisions, for making all these engineering solution optimization as well. So computer model now is widely used in most countries, in China as well, in our policy development, in our urban planning, in our even operation parts. The model is applied for all these aspects. But on the other hand, when we are doing the design work for each individual facility, for example, one or two, a major one or small ones, but then you have to understand the fundamental philosophy of that, and then try to make it, this properly. Again, you still have to rely on computer model to test various solutions. So modeling really has been helping us from all aspects, from planning, from making decisions, making policies, as well as for construction and also operation. Covers quite a wide range of areas. So technically, to achieve that, real computer model tells us a number of critical features. One is the baseline, what problem we are having at the moment, for example. So model tells us the whole system, model the whole system, model the current situation, and then tells us what problem we are having, what risk we are having. So that's very fundamental to understand the issues. That's first one. But then beyond that one, computer model can help us to make better decisions for solutions, as I said previously, and also for even providing us with fundamental technical features to help us make decisions for covering all aspects I just mentioned previously. So these are the main values I would say a computer model is helping us.